Okay, so back to this question. So yes, I was right. When n is less than m, y equals 0 is the horizontal asymptote. Alrighty, so let's go ahead and I'm just gonna write this information on the side. We have our vertical asymptotes, we have the horizontal asymptote, and we're gonna still have to create our chart. Okay. Oh, and the y-intercept. Alright, so let's create our chart. Alrighty, let's also have our coordinate plane. Alright, so 0, 0, that's our y-intercept. Okay, we have a vertical asymptote at -2, a vertical one at x equals 3. Always good to label your vertical asymptotes. And at y equals 0. Okay, oops. Alright, the y-intercept is there. Alright, that's the only point allowed to be there. Alrighty, so now let's plug in some points. So we're gonna have to plug in some values on the left and the right of the vertical asymptotes. Now, because there's more than one, we're gonna have to plug some values on the left of this vertical asymptote, in the middle, and then on the right of the rightmost one. Okay, so some values lower or smaller than -2 would be -3, -4, -5. Some values in between the two vertical asymptotes would be -1. We already have 0, 1, and 2. So -1, 1, and 2. And some values to the right, I always try to pick at least 3 points. Would be 4, 5, and 6, right? Just to you know, have enough points for it to look nice. And also see what's happening. Okay, so then let's plug these in, and then based on these ordered pairs, we'll plot them, connect them, see what happens. Okay, so I'm gonna plug into this bottom one because it's easier for me to plug in without using a calculator. All right, so again, you can use your calculator if you want to. So if I plug in -5, so I'm gonna do it up here, it's gonna be -5 over -5 plus 2, -5 minus 3. All right, so that's just gonna be -5 over -5 plus 2 is -3 times -8 is 24. Okay, so -5 over 24. All right, plug in -4. It's -4 over -2, then -4. So it's gonna be -4 over -14, which is 4 over 14. All right, plug in -3. That'd be need some space. -3 over -6 times -1. Right, so that's gonna be -3 over -6. Sorry, let me double check this one. Okay, so that's gonna be -3 over +6, which is -1/2. Okay, and then just keep plugging in. So let's keep plugging in, connect our points. All right, plug in -1. Okay, I do want to point out that using the factored version is okay if nothing cancels. Now, if something cancels, you do want to use your original function for the points where the domain doesn't exist, right? Because remember that if something canceled, that means that it's technically not part of the domain. For example, let's say it's x squared minus 4 in the denominator. You were to factor that, and it's x plus 2 times x minus 2, and then you cross something out. Remember that originally 2 and -2 makes the function not exist. So I would just be careful if something canceled, and I would just make sure I use the original function for plugging in values of the domain. Okay, but in this case, nothing canceled, and I'm also clearly not plugging in values in that would make the function not exist because I'm using points that aren't on the vertical asymptote. Right? So let's plug in -1. Okay, so that's just -1 over -4, which is positive 0.25. Okay, plug in 1. It's -1 over 6. And then continue the work. Right? So plug in 2. Alright, it's going to be negative 2 over 4. You can put the negative on the top or bottom. So that's negative 0.5, negative half. Plug in 4, 5, 6. It just takes a while, but it's easy to do. It's going to be 2/3, which is 0.67. Plug in 5. And last but not least, plug in 6. One-fourth, which is 0.25. Okay, so now let's graph these. Alrighty. In this moment, it would help to have a calculator. So. Okay, it's gonna be 0.2 something for this one. 2 over 7. Okay, let me get closer for the other one. Alright, 0.20 is closer. Okay, I think that's good. Oh, we need 1 over 6. Oops. And 5 over 14. Yeah, I do things like this sometimes. 0.3 something. Okay, of course, if you have a calculator, it's going to take less time and you're going to get closer with your numbers, most likely. Okay, but this is all I really need to graph. So this is going to be negative 5, comma 0.20. So it's going to be very close to the asymptote. Negative 4, comma 0.28. So it's going to be a little bit higher. Negative 3, comma a half. Negative 3, comma negative a half. So negative 3, comma negative a half would be right here. Okay, so let me check this negative 3. Oh, you see, this one, this was negative, my bad. Just give me a second. Yeah, these are negative. Okay, so I knew something was up. Okay, so negative 5, comma negative 0.20, so it's coming really close but on the bottom. Negative 4, comma negative 0.28. Negative 3, comma half, I already did it. Negative 1, comma 0.25. Okay, so for this region, it's getting very, very close to the vertical asymptote, but it's not touching. You connect your points. For the middle portion is going to be 1, comma negative 0.16, so 1, comma negative 0.16, very close to the vertical asymptote. 2, comma negative 0.5. And negative 1, comma 0.25. Okay, so connect your points. Because there's 1 on top and some on the bottom, it's a cubic function in the middle. And on the right hand side, we have 4, comma 0.67, 4, comma 0.67, 5, comma 0.3, so it's going lower, a little closer, and then 6, comma 0.25. So getting close to the vertical asymptote on both sides, but not touching. Getting lower and lower and closer to the vertical asymptote, but never touching. Okay, so there you go. All right, so that's that. I'll erase this. Okay, let's make sure we can graph number 5 and then we'll move on to the system of equations. So for number 5, we got multiplicity of odd, which means that you cross the x-axis. So it's going to cross the x-axis, means it's going to go through the x-axis. Okay, remember if it bounced, that means it would touch the x-axis and then change direction, but not go further than the x-axis. Okay, for the end behavior, it goes down when it's extremely negative and up when it's extremely positive. Okay, so down when it's extremely negative, up when it's extremely positive. Okay, something like that. Okay, and now we just have to do the middle portion. So for the middle portion, when you're at, for all these is going to cross, meaning that it's going to go through the x-axis. So at this point, I'm going to go up. Okay, now as I get to the other root, it's going to cross the x-axis, so it's going to have to start going down in order to go through the x-axis. Go through the x-axis. And then maybe I made this one too close. And then over here, it's gonna, again, multiplicity of 1, that's odd. It's gonna have to cross the x-axis. So in order to do that, it'll have to change direction and go through, okay? If it bounced, it wouldn't be allowed to go through the x-axis. It would just touch it. Let's say it crossed here and it's gonna bounce for this point, because it's a multiplicity even, it would change direction and touch the x-axis, but it would be not allowed to continue to go higher, right? So then it would have to go down or do something else based on if you have more roots over here. Okay, so this is what it should look like for number 5. Okay, last question, systems of equations. Okay, so the shortcut is that because you're solving for 3 unknown variables with 3 equations, the best thing to do is actually isolate for 1 variable, the easiest variable you can find, and then plug those into both of the other equations and then solve it like it's a 2x2 system, and then that's going to get you to have at least 2 variables, and then you can get the third one super easily. So that's being strategic. So let's go ahead and isolate either this x or this y, considering it has a 1 coefficient. It's going to be easier to isolate. So I'll just isolate x. So if you isolate x, that means I want to subtract y and add z, right? So it's going to be x equals -1 minus y plus z. Okay, so I just isolated a variable, and I'm going to plug that into both of the other equations and solve it like a 2x2. Okay, so for this one, I'll plug in the x that I just isolated. As long as your signs are right, you should get this right. And then on the bottom, I'll plug in the x as well. And then solve. Okay, so this is going to become and of course I have to put my like terms together, so okay, and over here, when I put my like terms together, I can move this -4 to the other side by adding 4, right? So this is going to be 20, okay, on the right. You can check it. For this side, I put my like terms together. And then of course I will add that 2 to have the number on the right hand side. Okay, so now you know how to solve this, right? This is a 2x2 system. You can use either substitution or elimination. Let's use green. No, let's use purple. So I'm gonna erase this now because we already plugged in and I need space. So we already plugged in x. So now that's easy. I just have to solve a 2 by 2. I'm going to do by elimination because I see 6z up here and negative z. So if I multiply the bottom by 6, I'll be able to cross out the z's. Okay, so it's going to be negative 24y minus 6z equals 22 times 6. Yeah, I like to do things without a calculator if possible, but there's nothing wrong with using one. Okay, and then now you're going to add the equations, and of course the z's will cancel, right? So then I end up with negative 31y equals, and what is 20 plus 132? 152. Okay, let me double check something. I think something happened for the bottom one when I plugged in, so let me just double check that really quickly. Yeah, of course, the bottom should have been, when I put my like terms together, I think I had put a different number on the right hand side. It's negative 2 plus 5, so this should be 7. This number should be 7. Which means that this number is 42, which means 20 plus 42, 62. Okay, now it's good. Okay, so this means that y is simply negative 2, right? Because negative 31 times negative 2 would give me positive 62. Okay, so we got that our y is negative 2. Our z would be easy to find. I can just plug it into either one of the top or bottom. I'll plug it into the top. So if I plug in, I erase this now that I solved for it already. Okay, so I'll plug into the top, and that's just negative 7 times negative 2 for y, right? Plus 6z equals 20. Solve for z. That'll be 14 plus 6z equals 20. Subtract 14, subtract 14, it's 6z equals 6. So z equals 1. See how nice that is? And then, now just plug in both into the top one, which we isolated, because remember we need to use all three equations. So for the first one, we isolated for a variable, plugged into the second and third, use it as a system of equations, use whichever method you want. We've got those two values, now we get to plug into any of the three. I'll plug into the first one, considering it's going to give me the x that I'm missing. So plug in y, plug in z very carefully, and this is going to be negative 1 plus 2 plus 1, so that's just 2. So we solve for it, so we're going to have our answer. You can have like a little squiggly considering there's more than 1. So x is 2, y is negative 2, and z is 1. We solved the system of equations. Okay. Alrighty, well that's it. Study, review, look over your notes, look over your homework. Make sure you know how to do this. Use your charts, use your calculator if you have to, and I'm sure you'll do great. Alrighty, see you later, students.